High Peak Courses are a British Government registered learning provider with the UK RLP. Hello, I'm Warren Leigh. Welcome to High Peak Courses. Lecture 3. Start to build the FEA model of the stowage unit. A stowage unit is a composite construction made from glass fibre in a phenolic resin matrix. This stowage unit was seen on board an Austrian aircraft in 2018. To obtain the interface loads that the stowage unit, or galley, etc., imparts to the aircraft during aircraft manoeuvre and gust loading, it is modern-day practice to create a finite element model of the stowage unit. The interface loads from the stowage unit are taken from the 4 feet attachment points. In this lecture, I will be introducing you to the two main FEA softwares that are used within the aircraft interiors design and manufacturing industry. These are called Femap, which is by Siemens, and MSC-Patran. Both softwares are used for FEA modelling of aircraft composite interiors. I say now that it's important to be aware that the finite element analysis models are composed of independent and separate panels that are connected at specific points by metal fasteners. These separate panels are shown in the image. The metal fasteners are modelled using MPC elements, multi-point constraint elements, which I will refer to in a later lecture. In either Femap or Patran, we start by creating a new database. All this means is giving your project a name and saving it in the correct directory. Shown here is a simple exercise in Femap. So in Femap, we start by creating 4 corner points of a panel of the stowage unit by entering the 3 X, Y and Z coordinates of each corner. You can create line 1 between point 1 and point 2. By selecting with the cursor point 1 and then select with the cursor point 2. A line will be created in Femap. Create the other lines in a similar manner as line 1 until all the lines that define the panel that you're working on are created. Then, create a surface. In the drop-down menus, you will find the creation of a surface. Click on this surface creation. Use either a 2-line or 4-line method. The word line might be edge or curve, so look out for that in Femap. From here in Femap, you will need to go on to make a mesh of elements and build the model. The philosophy of building this model I highlight as follows in the introduction to MSC-Patran. Okay, so now let's introduce to you MSC-Patran. MSC-Patran is a very familiar software within the aircraft industry. Open Patran, make a new database, i.e. make your name for your model and save it. Do not import the CATIA 5 or SolidWorks 3D model because we need a mid-ordinate 2D model. You could make the 2D model from the 3D solid model, but it is far quicker if you make the 2D model from the dimensions given on the 2D drawing made of the stowage unit. In Patran, Start by selecting the Geometry tab located to the upper left along the horizontal navigation bar. To create the geometry of the panel, select the Geometry tab in the upper horizontal navigation bar. To create the grid points, go to the drop-down menu in the upper right of the screen and select Create Grid Points. Enter the coordinates of each of the 4 grid points that define the panel you are working on. So the coordinates will be X, Y, and Z. I now give you a short movie showing how I do this process of creating points and lines in MSC-Patran, which I have on my Dell laptop. My apologies that the quality of this video is not so clear. The 4 corner points are created. Now, a short movie showing how I create curves in Patran. Now a short movie showing how I create curves in Patran on my Dell laptop. From these curves, I define a surface. To create the surface, in the upper right drop-down box, select Surface. Choose either the 2 or 4 curve method. For example, select the bottom curve and then the top curve. For example, select the bottom curve and then the top curve. Now, before we can create a mesh surface, we need to define the number of mesh seeds along each edge of the panel. The panel I refer to is where we've just made a surface. Now, this will control the number and the size of each element using mesh seeds. And I've used 5 mesh seeds on the bottom and 10 on the vertical and 5 on the top. Next, select quad 4 elements. These are the elements which will produce accurate results. Now a short movie producing a mesh on the surface. This is a 5 by 10 mesh of quad 4 elements, as indicated just a few moments ago to you. This mesh panel should be now placed in a group in Patran. Go to the Group Creation tool, which can be found in the top left of the screen. We need to create a second and all the other panels in Patran. For the second panel, create point. Enter the coordinates for the new point of origin for the second panel. And this will be x equals 0, y equals 0, z equals 0. This will be a duplicate point and will share the same space as the origin of the first panel. And Patran will ask you if you want to create a second point, a duplicate point with the same coordinates, and answer yes. Now you need to check if these 2 points do share the same place in 3D space. You can do this on the right hand side drop down menu and look for, I believe under elements, the word view. Put a box around the origin of the 2 panels and you will see there'll be a readout actually confirming they are 2 points, both with the same coordinates. Now you will need to create curves for the second surface. The first curve on the bottom or the top of the side is going to share the same space but not the same point. So you'll have to learn how to edit and be selective of that point in Patran. Once you create the second surface, place these elements only into their own group. Now create all the other surface of panels for the stowage unit in the same way. Each panel mesh with quad 4 elements and place each individual panel into its own group. Each panel when created should be placed into its own unique named group. Now we do an FEA model quality check. A very simple check is as follows. We need to ensure that each panel of elements has remained as separate individual groups of elements. This is important in the methodology, and also it will be checked by your peers when you finish doing your stowage unit. So you need to demonstrate you do have each panel independent of the other panel. The panels, as I mentioned before, will only be connected using MPC elements. Now, the way you do this, you post 2 groups of elements, for example, together. In the drop-down menu, select verification and boundaries. Using this command, you should see a line between the 2 panels of elements. This verifies that each panel of elements is independent. You can press the other button to reset. When you're completed meshing all the panels and done the verification, post all groups of elements and rotate to visually inspect that you have all the panels of the stowage unit meshed and in the correct position and orientation. In this view, you can see the 4 feet attached to the underside of the floor panel. The feet are formed using triangular elements called trias. These are 3-noded, in some cases 6-noded elements. Each foot will be grounded using bar elements that are defined with translational and rotational stiffness. It is prudent to do all your geometry dimensional checks on the model that you've created to make sure that these panels are the size that are on the drawings. To summarise, this is a 2D mid-ordinate finite element model, constructed in either Femap or Patran. Each panel is independent of the adjacent panel. Each panel is connected to the adjacent panel by MPC elements.